every so often, humans do something that makes you stop and think, who exactly are we trying to impress?
Yeah, and one of the boldest examples of this is a shiny metal disk that we launched into deep space in like the late 1970s. And this was supposed to be a message that was meant for anyone or anything in the universe that might find it long after we're gone.
And you might be thinking, it's a grand speech or it's a beacon or something like that. But no, it's not a grand speech. It's not a beacon. It's not a digital archive or like anything useful, like a pen drive of all human data. It's just a record, like a music player, a literal record.
Which brings us to today's topic.
Yeah, the golden record. It's strapped to a spacecraft. It's strapped to the Voyager that's already left the solar system. And it's basically our mixtape to the cosmos, except we made it analog on purpose. And we hope that somebody somewhere knows how to play it.
And if nobody ever plays it, it's at least a very expensive paperweight.
Yeah, it's made of pure gold, bro.
Yeah,
So let's start simple, okay? The golden record, it's a physical object, okay?
yeah.
It's a copper disc covered in gold, okay? It's not pure gold, like all of it, but it is covered with pure gold.
Gold
Okay,
plated, yeah.
gold plated, exactly, and it has instructions etched on the outside. It kind of looks like this. Okay,
Nice.
yeah, it has those instructions etched on its surface on the gold, and it's not like sentimental sketching. It's engineering. Okay,
Yeah.
these choices of using gold was not just for like flexing on them like that we're rich or whatever. Like it was materially chosen, like engineer specifically chosen, okay? And it wasn't like for it was for not for redundancy or stuff like that. It was analog encoding for a reason. It was all chosen to survive a crazy long time in space, basically.
Why analog? Wouldn't digital be better? I mean, after all, even even in the 1970s, we had like computers and telecommunications and all of that. Why analog messages? That's just redundant,
Good
isn't
question.
it?
Good question. Yeah. See, the thing is, digital stuff in general decays if you don't know the format. Analog is
Yeah.
more of a primitive type and it's more legible across unknown tech. It's more accessible, you can say, right? In one
Mm.
word. Think of it like engraving a message in stone versus saving a file on, or in like saving an image in a JPEG format, for example. So
Mm.
people in the olden days would not be able to open the JPEG format because it's not invented yet. Versus
Yeah.
the stone thing, it's like universally accessible. Like not universally, I would say. Universally is a bit of a stretch, but it's more accessible than relative to the digital equivalent or the counterpart, right? So the record is a human readable relic, basic diagrams, pulsar maps, and then sounds and images echo that are encoded as grooves. That's why it's a record player. But yeah,
Yeah. Yeah, so this record is basically it's less of find my Spotify playlist and more of archaeology starter kit, right?
yeah, more or less. It's like kind of like a time capsule, you know? It's built
Yeah,
to be
yeah.
interpretable
Mm.
by a totally alien mind, which I highly doubt is going to be interpretable by a totally alien mind because it's hard for even like if you go to the average human and give this to them, like what do you expect they're going to think? What is this?
To me,
So
if I didn't know anything, it just looks like a golden moon with some stuff, like some drawings just written on
just
it.
like random stuff, right? On the
Yeah,
moon.
exactly.
Yeah.
Yeah,
But we might delve deeper into this, but each of those small diagrams has very significant meaning to it. And the scientists are hoping that the aliens can uncover their hidden meanings, their puzzles,
not
and
not
find
just
it out.
aliens, it could be anybody, anything. Who knows? There
Yeah,
might be
anything.
an Earth replica out there. We
Robots.
don't know. We're
Yeah,
just
that's true.
hoping
Anything's
that
possible.
something receives it. Okay. So we know
Some
that.
that
Huh?
doesn't retaliate back, rather than it just messages back. It doesn't retaliate or attack.
That's the risk that you're kind of taking, right?
Yeah,
We just have to
because
wait and watch.
this one, for example, this one,
Yeah.
this basically tells the location of our sun with, I think, pulsar imaging or something like that.
Hmm.
We'll tell exactly what it is a bit later, but it's it's pulsars. Yeah, using 14 known pulsars. from near the sun, it just tells you the exact location of our sun. And if you know the location of our sun, then you know our location basically. Like, come on,
Yeah,
it's
yeah.
like 8 minutes away for light, so not that far.
In like outer space terms, we are extremely close to the sun. Out
It's
on the
all in the
scale of
same
the
galaxy.
universe. Yeah, yeah.
Exactly. Very
So
close. So
what
so
what
this
we
this record is
yeah.
basically meant to be interpretable by a totally alien mind, or at least by someone who's curious enough to decode diagrams and patterns, or like have the enough free time to do it.
Okay.
Yeah.
So we know that this record is physical, and we also know that radio signals are really different, right? They radiate outward and they fade. And Earth has been broadcasting these radio signals for a century now, hoping that someone out there will listen, right?
Yeah.
That radio bubble is out there right now, but unfortunately, it doesn't last forever. Even though you might think that, energy is conserved, yes, and that in outer space there is nothing really to diminish that energy. But this radio signal, this beam of energy that we are sending outward into the universe, it doesn't last forever.
Electromagnetic wave,
Yeah.
right? Yeah.
Yes.
Yeah, so it's basic physics, right? Because signal strength actually follows the inverse square law. Basically, simply speaking, it just if it's like 2 squared is 4. If you double the distance of the light traveling or the wave traveling, the power of the wave drops by 4. So it's bad. It's kind of like if it was the other way around, it would be like as in if it was 4 times the distance and 2 times the loss of the power, that would have been better. But point is, the more the distance, you have the squared amount of power loss. Okay, so that's a lot of power loss for each increase in the
Yeah.
distance, right? So, like for example, our TV and radio broadcasts, they were broadcasting into space as well. Like they're always broadcasting into space,
Yeah.
but the intensity gets weaker and weaker, so the dissipation and all that, it doesn't really affect much. But dispersion from the interstellar medium scrambles the signal. That's
Yeah.
it.
So your neighbor's sitcom is now just a whisper across light years.
That is true. Everyone's TV serials and their dish TV and radio antennas and all the podcasts or the radios, the FM radios that people listen to, that's all broadcasted into space as well, somewhat. So, thing is, there's it's actually worse than one might think because much of what we listen to on the electromagnetic spectrum or even because the spectrum is huge, right? It contains not only radio waves, it contains a lot of stuff like gamma rays, X rays, ultraviolet, visible, infrared, magnetic waves, and yeah, radio waves, as I said. So, point is, much of what we use is always leaking into space 24/7. Like analog TV was like when it was used well back in the day, or high power beacons. They were that all that has decreased in use, but it's still radiates out into space. Now we've shifted to cable, fiber, low power digital transmissions. So the bubble isn't steadily expanding like a bright sphere. It's actually dimming in parts, but future detectability depends on the energy, the direction, and the time in which we decide to send out those radio waves in, right? Or the electromagnetic waves, not necessarily radio.
Yeah, our loudest signals are already fading into the cosmic static.
That's true. Also, deliberate broadcasts like the ARCIBO, is that how you say it? ARECIBO.
I think I'm hoping.
So, yeah, the RCBO message are different from accidental leakage. The RCBO, for example, was a high power, targeted, and really short message. It's like a deliberate beacon requires energy and intention, right? You don't like just send out a random beam of high energy
yeah.
electromagnetic waves just randomly, right? I mean, they're cheap as well, okay? Like accidental signals are cheap, but they're weak, so that's kind of useless.
Yeah, and this leads to the core tension. Do you build physical messages or do you spend energy on loud directional radio beacons? That is the
Yeah, that is true. That is true. And as everything, both of them have pros and cons.
Of course.
Physical probes, yeah, physical stuff like physical messages, as you said, physical probes, they can survive long times, but they have tiny cross sections because they're physically, you can't like build a huge golden disc, right? That
Yeah.
is like,
And then
it's a bit
then
of a
getting into
stretch.
travel in space is also a task, right?
Exactly.
That is one more problem.
Exactly.
Yeah,
Exactly.
the more mass it has, the more problem you have sending it our universe, like beyond our
Our
Milky
solar
Way,
system.
our solar system even.
Yeah. So radio beacons, on the other hand, because it's just light, you're propagating light.
Hmm.
It's massless, right? It's photons. So they can like have exponentially more. They're exponentially easier to send out that compared to like a physical golden record, or the fact that the light waves can be sent out multiple at a time in different directions, but to send out multiple golden records is just going to be, it's not feasible, right? Because you just need, or to make such a big golden record, it's not feasible to send
Yeah.
it in that one direction. It's not going to be easily intercepted, as I said, and as you said earlier, right? Because
Hmm.
it's like understood, right? But
Yeah.
thing is, with the con of having directional radio beacons, they do fade fast and they do require a lot of energy. If you wanted to travel across the universe, or like across our observable universe of 93 million light years,
I don't know the
93.5
exact
million light years, I
number,
think.
but it's somewhere close to that, I think.
Something like that, right?
Yeah, yeah, yeah. I think it's billion, not million, but same difference. As long as we
I
are
mean, at
concerned.
that point, yeah, I think it is 93 billion light years across.
Yeah,
Yeah,
it's a
yeah,
B. Yeah. Okay, okay. Leave all of this right now. Okay. We've talked
yeah.
about your physical probes or whatever radio transmissions that you have. All of that is fine. Okay. Say that we get the message out there. Okay. Say that, for example, someone is living out there and they receive the message. But how do you make something that is interpretable by a mind that does not have maybe eyes, ears, human DNA? What is the guarantee? How do
There
you,
is no guarantee.
yeah, how do you
That's what the thing
transmit
is.
that message such that they understand it?
That's the thing. That's another issue with the golden record.
Yeah,
Because you can't even take it like at face value. You have to take the golden record with the grain of salt, is according to me. Even stuff like what we might consider to be universal, or what like constants might be universal, like the speed of light might be universal. I'm not talking about that universal. I'm not talking about fundamental constants. I'm talking about
yeah,
stuff like maybe up and down. That might not be a universal concept, right? Or math patterns like the Fibonacci series might be, it's a series, it's there. It's not like the aliens don't have, not they're not denying the Fibonacci series, but they might not like have realized it, right? They didn't have Fibonacci. So there's no guarantee for anything, right?
yeah.
So the scientists that made the golden record, the physicists and the astronomers, the NASA engineers, I'm assuming,
Yeah.
they started with universals. Okay, they took these math patterns or prime numbers and these fundamental constants, and they used diagrams rather than English text, which is a very good idea, to
Yeah,
as very good as in relative to using English. It's still
of
not a
course.
great idea to use diagrams because we still don't know how they're going to access it. But they have used diagrams to, like, for example, define the transition of the two hydrogen states. It's sort of a universal clock. Again, it may not be universal to them.
So,
They
yeah,
might not realize it. Basically, the idea they used was pick anything that physics literate species could find meaningful, hopefully. So, like for example, the hydrogen clock. It's the shows this is it's somewhere here. Yeah, okay. So this is indicating the transition of two hydrogen atoms, and the arrows indicate the spin of the electrons and the protons. It's all given if you just Google. I don't want to get into the weeds of it.
yeah.
Uh, Pratham, you can if you want to, but
See,
I think they can read it on their own. It's a bit, it's too out of the scope of the episode.
basically, one of the reasons they have put it in there is because it's something that is very, very fundamental
Right.
to the foundation of not only physics, but the science that we have built for our understanding, right? Hydrogen is the smallest atom that we know of. So that is something we call it the building, one of the building blocks of our universe. And that's why it's
Exactly.
extremely important to us. So we are just hoping that something like this might be more important or equally as important to someone who is out there. That is just one hope that we have. But I still think that these universals are just assumptions because, like Arnav said, like you said, what may be important to us may not be important to them, or they may not have recognized it. For example, an intelligent species outside our Earth, wherever it is, it might not prioritize the Fibonacci sequence or prime numbers, say. So we don't really know whether it's a priority and whether they will be able to decode it. But regardless, we are sending it.
Yeah, and another thing is that let's assume they know it and they can decode it, but what if they're just like so far advanced that they don't even like care about this anymore? Like,
That's on us.
yeah, that's a skill issue on
We're
humanity's
too
part.
far.
Yeah. And this reason of these assumptions is why redundancy matters because that's why there's so many diagrams. That's why there's not only one diagram. That's why they use multiple layers like basic math, physical constants, then images, and then there's sounds. The sounds are if you have a record player, like I don't understand how they expected someone to have like even I don't have a record player.
Yeah, but it
To,
was the 1970s, so like vinyl records were like really
yeah, that they were the thing,
on.
you know,
Yeah. Over here, of course. How do you know?
Yeah, so I don't know why they picked a record like to play like that, but they have sound, okay? Also, information theory helps. So they want to minimize ambiguity, right? They want to send another thing is they have sent they've encoded binary, I think. As far as I know, they've encoded binary, right? Yeah, it's binary code encoded in the this thing. This is the golden disk, but like diagrammatically, where the sounds that they play, I think that is kind of like I'm assuming like like
Ones and
ones and
zeros.
zeros. Yeah. That sounds whatever the sound is, like it'll be like maybe a long beep and a short beep, kind of like Morse code. But point is, binary is something that the humans have invented.
Yeah.
It may not be known or used by them. They might be using ternary or base 10 stuff, like who knows. So
Yeah.
that's another thing. The sound first having a record player, and second thing is even if you have a record player, it's in binary. Okay. So the point is that they want to minimize ambiguity, right? So they send patterns that compress well into simpler rules. Like a message with structure is more likely to be distinguished from just basic noise, which the binary code might as well be basic noise to them as much as it is to humans, because humans don't really speak in binary.
Yeah. If you can't share words, just share math, right? And I think that
Yeah.
another advantage of sending this disk that we have is that the information on it will more likely remain forever. So say even if the Voyager gets
Interesting.
like disbanded or whatever, this disk can just normally float into space wherever. Okay, and if somebody catches it, they will still be able to access the information on it, and it would not really fade away. That I think that is another pro of this.
Interesting. Also, since you mentioned the Voyager, we've mentioned it earlier as well, but an interesting fact I want to point out is like it relates to the fact that more mass is harder to
Yeah.
propagate through
Yeah.
space. The Voyager spacecraft is the Voyager 1. NASA's Voyager 1 spacecraft is going to be one light day away from Earth in November 2026.
Still 1 year to
Okay.
go.
Yeah, so
Almost.
all more like basically a year. That's also I think we're gonna get that before GTA 6, by the way. Thing is, it's gonna be like a billion miles or something like that away. Point is, it's one light day away. After like I think how long has it been?
It was sent in the 70s, I think. I'm not sure which year, but
I
definitely
can
long ago.
yeah. So it's gonna happen around November 15th, 2026. And I think GTA 6 is releasing on November 19th. So this is happening before GTA 6. What?
You may never know, they may push the date again. Said
Uh,
May, they said May something
no.
something
But the fact that this is
2026, then
happening
they
before
pushed it.
no, but if the fact still says that this is happening before GTA 6,
Yeah.
even if they push it till later, so that's fine. So
See,
great, we are having
physics
Voyager reaching one light day away.
like this is more or less predictable.
Yeah.
Human actions are less predictable. That
That's
is
why
just
people study psychology to understand the human mind and fail miserably because no one knows what is happening. So okay, so as you said, you can't really decide, right? If you can't share words, you have to share the math behind it, right?
yeah,
We have to also consider modality because radio is electromagnetic, it's an electromagnetic wave, as we've said multiple times. The golden record, on the other hand, is mechanical slash visual slash like sound, right? Mechanical in terms of you have to play the record, right? So
yeah,
each channel has different failure modes. It accounts for various things. It doesn't account for everything by any means. It accounts for more than one thing, is what I'm trying to say. Because it has redundancy, it has backups, right? If you assume the recipient can sense electromagnetic radiation, for example, and reduce frequency standards, then radio works, because that's the alternative to using the physical golden record. But if you assume they can examine a solid artifact, physical encoding works like the golden record.
yeah. Basically, we've tried to consider all of the different possibilities. That's why we have sent them electromagnetic, visual, and if necessary,
Audio.
audible types of information to them so that they can access it in whichever
Another
medium that they have.
Yeah, another
Yeah,
thing I think you can count this because it's engraved, right? It's encoded. So
yeah,
by touch they can also feel it.
yeah, probably
So that,
kinesthetic.
I mean, it's not going to be like unless they have like because the diagram itself is going to be so small, they'll have to like really sensitive stuff to feel it. Because if we do it, we are not going to be able to
Yeah,
tell the intricacies
probably.
of each of those lines because they're a bit too precise. But if they have precise ways of touching it, then
Probably.
that is another mode that they have taken into account, I guess.
And I feel that another layer to all of this is interpretability, right? Suppose they detect somewhat of a repeating pulse at a frequency that is corresponding to hydrogen. That's a
Hmm.
hint for them. But turning that hint into a message really needs somewhat of a decoding map, right? Some some script or something that they should be able to understand with. Have the
English.
instructions, yeah. But
No,
the
like
instructions are in
e-
Swedish. The instructions
yeah.
are in Swedish, and you
No,
are
no. Even if they're in
trying
English,
to
I can.
interpret it.
I have the diagrammatic representations, and I can understand what it looks like. The other intelligent life does
Yeah.
not have an instruction manual, and it doesn't understand even if we give it an instruction manual.
I thought you were talking about you, that if you were trying to assemble it, you can see it, but the instructions are in Swedish. But
No,
whatever.
both.
Basically, I feel like it's giving someone like a chessboard, but and giving them no instructions on how each piece moves or whether there are pieces at all.
You're just giving like the plain board, like here.
Yeah, this is it.
Yeah, that's
Do
useless. Yeah,
whatever you
exactly.
want
That's what I'm
with
saying.
it.
Yeah, that's what I'm saying. That's why I was surprised with the golden record. Like that's why we were
Hmm.
talking about it because still the trick is like let's go back to the record. The trick is to use decoding scaffolds, kind of, okay? Like
Okay.
stepwise instructions that build complexity gradually, okay?
Hmm.
Thing is, the first step itself might not be reached, but let's like we're being optimistic here, like the
Hmm.
scientists were back in the day. Start with simple counting, then move to binary images, then to analog sound mapping. Really small steps we're taking over here. Just like baby steps, right?
Yeah, yeah,
And
yeah.
that's what the golden record attempted, a literal map to learn from, but I think the steps they took were a bit a bit too big. Yeah, right?
Yeah, yeah. And relating to this also, we talked about survival, right? The survival of the record itself. It,
Exactly.
a radio pulse has a reach that is limited by power and time. A probe is a physical object that can just sit on a trajectory for millions of years. Which one is more likely to be found? That that becomes another question for us. And I feel that it depends on the metric. If you measure like per reach per watt or something like that. Radio wins in the very short term, but I feel like we have discovered our universe enough to know that the short term doesn't really hold anything significant for us. And if you measure, say, longevity and chance of interception over maybe geologic time scales, a robust
Right.
physical device like a probe, it may win, and it has more
Yeah.
probability of winning. And But we still have to consider that there is a very low probability in both cases. Okay. Space.
We're talking about relative probabilities
Yeah.
now at this point.
Yes, that's correct. That's correct.
The space is just so big.
Yeah, exactly.
We don't
And
know if it ends.
right, neither of them is a guaranteed success, right? But each of them serves a
It's far
different
from
goal.
guaranteed. It's the opposite of guaranteed. It's almost guaranteed to fail.
Probably.
Yeah,
Never say
yeah.
never. But each of these mediums, they serve a different goal. For maybe someone's listening now, or that we have the decoding or encoding, sorry, on the record, or you have somewhat of an artifact visually that someone might find this later or whatever.
I mean, see, it's kind of like how people bury those like small time
Time
capsules
cap. Exactly.
underground. It's kind of like that, except you're burying the time capsule in like the Mariana Trench and you're expecting a human without any oxygen, without any diving suit, and without any arms or legs trying to go get it. That's how that's how hard it is. It's basically
True.
impossible, right?
Yeah.
So basically, you can think
Hmm.
of it like radio is shouting across like a square field and it probes as burying a message in a time capsule, as I said, across the countryside. So both cost different resources and both assume different search behaviors from the finder, and both have their pros and cons.
Okay. What if we think about the other side now? Okay. What if we
Okay, yeah.
flip the whole situation and we say that an alien civilization wanted to communicate across the millennials? What do you think they would do?
Interesting. It's kind of like I watched this movie called Arrival. It's
Hmm.
about it's Jeremy Renner.
Okay.
It's basically how aliens they want to communicate with us. They literally
Oh,
just show up on Earth. They just show up.
interesting. That
So
is an option.
yeah, they just show up. That's one that's one option. But the more realistic one is when they don't show up, they like communicate long distance. Is they build in the math. They use stable physical media. Maybe they like stash something at Lagrange points, like which are basically so-called. You can say I think stable equilibrium points, kind of where I
Yeah.
think they're between the Earth and Sun, and basically how this is where they this is where NASA or other um,
They
space
send their
agencies of the world
satellites.
place their satellites exactly
Yeah.
because it's very easy for them to place it there and they just stays in orbit at that point without much like it's like basically God made it so that people can put those satellites there so it's very convenient for them. Otherwise it would have been really hard. That's all.
Basically, one way to explain it is that you know that there are a lot of different masses out there in our solar
Yeah.
system that have gravity, right? Each one wants
And
to
and these
pull,
are all measurable. They can
yeah,
be
of course.
simulated very accurately.
Each mass wants to pull you towards it. Okay, but you get to one point between all of them that really each one wants to pull in different directions and they just cancel all the forces out. And you get this one
Exactly.
sort of net equilibrium point where you can remain stable and you can,
And
you can collect all the
the good
information you
thing
want.
is there are multiple of these points. That's why they're
Yeah.
called Lagrange points, and
Yes.
that's why they're like opportunities for so many satellites to
Yeah.
exist over there, and the fact that even if they're like slightly off they can like recourse and readjust very easily because the net force is still very less in that area. Basically they can stash something at the Lagrange point, for example,
Hmm.
or a long-lived asteroid, for example, because an asteroid might be an alternative for putting it in the Lagrange points, or they can encode data in an extremely stable material like glass or crystal, or they can modulate neutrinos. They can modulate neutrinos if they want to be fancy, you know?
But I feel that the practical approach favors some sort of redundancy. When you take multiple channels like maybe electromagnetic beacons, physical objects that you can place in predictable orbits, or even gravitational markers, the aim would be to increase the chance that some of these messages survive and can be recognized as artificial. Maybe if you send something like neutrinos, we may not be that equipped to really catch them or intercept them, I would say. Right. And
Yeah,
the and again the message should also be designed to be self-explanatory, right? From whatever basic stuff that we know, they might know more. So we also need to take that into consideration. And it needs to be something that is of real value, like maybe something related to science, physics, that, it can stay constant
Yeah.
throughout. That is the
Yeah,
hope.
something under
Not,
the sciences rather than or it's like not STEM. It's just going to be science or math.
yeah,
It might be physics, it might be chemistry, it may be biology, might be math, but other stuff is all like human specific and
yeah,
like then you're not gonna tell like the latest Taylor Swift song or on the
exactly,
thing, right? That's
exactly.
completely something that's like it's irrelevant to the point, right?
Yeah, just a simple demonstration of math, physics, chemistry, biology, whatever you want, and maybe some instructions on how to reconstruct it from more complex context. Maybe.
Yeah, maybe. Short summary. We made a golden record, except we, as in I'm talking about, I'm speaking for humanity today, you know. Pratham and I, we are the sole representatives of humanity.
That's true. On
We are
on
the
this
go-to.
podcast, it's an intergalactic podcast, by the way. We are relaying this as well into space.
Exactly.
Let's
We
hope.
use radio and we don't use golden records. We haven't tried it yet because reeling up the golden records, we have to encode it like physically. And each episode, we don't want to spend a golden record on it. So we're just sending it out in radio waves. But we've made one as we just made a prototype. Like that was the one Voyager spacecraft one, you know. It's there. Basically because physical messages, it's for like it's once we send it out, it's there forever, basically, like
Yeah,
almost forever at least. It has longevity,
longevity.
right?
Yeah.
Exactly. But we also daily, like, or I'd say every time we upload or every time we post out something, we blast radio because it reaches quickly, way faster because it's traveling at the speed of light, and also because it's massless. Thing is, both are constrained by physics, both the record and the light speed.
In very different
Radio,
ways.
yes,
Nonetheless, the
but nonetheless
probability of
constrained.
both of them reaching is really, really small. But
Thing
I
is, we
feel
have
like,
some intergalactic listeners,
yeah,
though. Thanks.
I feel like the physical one just has a little bit more probability than the radio ones, but whatever. Let's see. Let's check back in 1,000 years and just
Yeah, 1,000 might be
wait.
a bit too less. It might be like a few million years until
Probably.
humanity becomes like a type 3 civilization or whatever,
Yeah.
when we can
So,
actually traverse the
hmm,
stars and all. So basically, there are, as we both said, like it is all constrained by physics, like the inverse square law, dispersion, loss of energy, conservation of energy is not energy is not conserved in space because of the loss of radiation, loss of energy due to the radiation, like that's dissipated in the vacuum of space as well, and in general survival of in the interstellar mediums that it goes through.
basically, we've adopted, like in a nutshell, we've adopted two strategies. One is for the very short term, one is for the very long term. But neither
Right.
guarantees contact, but both tell some sort of a story about us. That we are curious, at least some of us are curious, science focused, engineering focused, and probably a little bit stubborn.
Yeah, humanity is really curious, really engineering focused, and really stubborn.